This is the Masking Handbook for Audiometry. This video looks at undermasking when not compensating for the occlusion effect. Let's look at some values that can be used to compensate for the occlusion effect. Note that supraoral headphones produce more occlusion effect than insert earphones, unless the insert is not inserted deeply. For this and other reasons, a deep and snug insertion of earphones is recommended when using those devices. What can happen with the occlusion effect? If you do unmasked bone conduction testing on a subject, you might get the results on the left. If you take the same subject and place a set of TDH headphones on their head and retest the bone conduction, you might get the results on the right. If the person has a robust occlusion effect, it could affect the unmasked bone conduction results very much. I recommend always doing unmasked bone conduction with both ears unoccluded. You won't need to accommodate the occlusion effect when using the optimized method, since that method is only used with asymmetrical hearing losses, and the initial levels of masking will tend to be delivered at almost a maximum level. So we'll be thinking of the occlusion effect when using the plateau method. Here are the three building blocks that are used to create our initial masking level for the plateau method. We see the first two items are compensation values that don't really provide a masking effect except to compensate for situational factors. The first is the hearing level. The masking noise must reach at least the threshold of hearing into the ear it's being delivered. The second is to compensate for a possible occlusion effect. These compensation items are foundational levels as we build up our masking. The third component is to add an arbitrary amount of actual active masking. We have a mild hearing loss here in the right and good hearing on the left side. We have some unmasked bone conduction thresholds with the bone conductor placed on the right side. But we can't know which ear is hearing these bone conduction responses. It's possible that these bone conduction responses came from the left ear, so we'll need to mask to see what kind of hearing loss is happening in the right ear, because at this point we can't be sure. So the left ear will be our non-test ear, and therefore the ear will need to mask. Let's look at 500 Hz. We'll have to decide on an initial masking level. Here are our three components to do this. What would happen if we ignored the occlusion effect in this situation? Let's take a look. We'll need 15 dB of masking due to the hearing threshold level of the non-test ear. And we'll add 10 dB of active masking to this value to come up with an IML of 25 dB. We should be good to go, right? Not so fast. Don't forget we'll be using TDH headphones to deliver the masking noise. Having the phone in position to deliver the masking noise may create an occlusion effect. Sometimes it could have a dramatic effect on the non-test ear's ability to hear bone conduction signals. If the unmasked bone conduction results were actually coming from the left ear, as suspected, it could shift the bone conduction results by a dramatic amount. So our overall bone conduction results that we're trying to collect with the device on the right side could be improved by these amounts simply by having the headphone in place on the left side. Although we can introduce 10 dB of active masking to the situation, we've also potentially improved the bone conduction hearing of the left ear at 500 Hz. So we have an active masking level of 10 dB, but we've improved the bone conduction hearing by minus 20 dB. The total masking effect, therefore, would be minus 10 dB. Our initially masked bone conduction threshold from the right side could be 10 dB better than the unmasked bone conduction result. Now let's try it with all three of our components, including the occlusion effect, into the formation of our IML. This time we'll include both compensation values. We'll compensate for the hearing level, 15 dB, and the potential occlusion effect at this frequency for this device, which is 20 dB. Finally, we'll add our 10 dB of active masking. So our initial masking level will be a total of 45 dB narrowband noise. Here are the IMLs for 500 and 1000 Hz using this method. With appropriate levels of masking, we can collect fully and appropriately masked bone conduction hearing thresholds. In this case, it's a sensory neural hearing loss, as the bone conduction threshold shifted with the introduction of the masking noise to the left non-test ear. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.